The total amount of a certain substance present in a laboratory experiment is given by the formula A equals A sub 0 times 2 raised to the h over 5 power. Oh my goodness. Where A is the total amount of the substance h hours after initial amount A sub 0 of the substance began accumulating. So you've got some growth happening here. You've got a starting amount and it's growing based on a certain number of hours that pass. So we're going to use this formula to answer this question. Which of the following expressions gives the number of hours it will take an initial amount of 10 grams of this substance to accumulate to 100 grams? So A is the total amount of the substance after growth. So that's going to equal 100. A sub 0 is the starting amount of the substance. That's 10. H is the thing we want to know. Which of the following expressions gives the number of hours? So we have this equation now. It looks horrible, but we can just plug in these numbers. So 100 equals 10 times 2 raised to the h over 5 power. That's what we're dealing with. And we want h by itself. So normally, to get h by itself, we can just divide by 10, and we're going to get 10 equals 2 raised to the h over 5 power. Now, we need to do the log ride. We need to convert this thing. We need to get h by itself. If you didn't have any idea how to do that, you could just plug in some of these numbers over here for h and see what you get. So you could just take, for example, does 10 equal 2 raised to the 5 over 5 power? So we're putting in 5 for h. It doesn't. So A is I'm gonna rule out A. Could I put in 25 for h? And so if I do that, this is my equation. Does 10 equal that? And it does not. So I can rule out A or B. The next two, your calculator can't really handle them, most likely. I doubt that your calculator has a base 20 or a log base 2 button on it. It maybe does, but most don't. So we need to figure out how to convert this equation here and to get h by itself. We're going to do something that your Algebra 2 teacher called the log ride. And I'm just going to write this equation like this: 2h over 5 equals 10. This is the exponential form of this equation, and I need to put it into the log form. And to put it into the log form, just to remind you, if you had some number like x raised to the m power, and that equaled n, we could rewrite that equation as the log base x of n equals m. So that might just seem more confusing than helpful, but basically these are two different ways to say the same thing mathematically. This one is exponential, this top one is exponential. We're used to seeing that. This is a log form, and it might look like you've never seen it before and have no idea what to do with it. It's similar to statements like 2 times 5 equals 10. We could say the same mathematical reality by saying 10 divided by 2 equals 5. Those are saying the same thing mathematically. It's just that we're saying them two different ways. Similar with this. We're saying the same two things mathematically, just in two different ways. So I need to take this 2 raised to the h over 5 power equals 10 and convert that to log form. I'm going to do something that your Algebra 2 teacher called the log ride. And the log ride asks you to kind of take a line and go down through the first number and up through the last number and point to that exponent. And then we're going to rewrite this as log base 2. We went through the first number. Log base 2 of 10, the last number, equals h over 5. There we are. And now, to get h by itself, we would just multiply both sides by 5, by 5, and we'll get 5 times the log base 2 of 10 equals h. 5 times the log base 2 of 10 is c. That's our answer. Took a lot of work to get there, but we could have just ruled out a and b from early on. And then if we just looked at these numbers that are in here, I don't see the number 20 showing up any place in the question. I do see the number 2 showing up in the equation. And so I could have just ruled out D because that number just doesn't make sense. I hope that's helpful. Go be awesome.